Now, once we understand how to simplify algebraic fractions with statements like these, we have a fair idea of how to treat with algebraic fractions. And once you remember those key little things like when we simplify, how to simplify, and the furthest bit of simplification that we could get to, we could work on some more. So let's take a look at another algebraic fraction type of question where we have to simplify the statement, and let's see if we're able to simplify this one. Now, of course, like I mentioned earlier, algebraic fractions aren't only going to look like the ones that we looked at. It can also be that you have algebraic fractions with denominators that are algebraic expressions. Now, when it comes to dealing with algebraic fractions where you have a denominator that is algebraic, to get your common denominator is a little bit simpler in terms of sometimes it's just to take the product of the two, right? And no, you don't really need to expand the brackets and simplify that statement. You just want to write it as a product, right? Now, there are some scenarios where both of the denominators, if you looked at them, one might be a factor of the other, and in such a case you would want to use the denominator that contains both of the denominators, right? So for example, just to illustrate so it wouldn't sound so complicated, right? Let's just say you had something like a denominator of x and a denominator of x squared. In a case like this, because x squared contains a factor of x in it, your common denominator here would be x squared, because it can contain the factor of the other denominator, right? So that's one. And also there are more complicated looking types of denominators as well. So let's just say you had something like x plus 1 and you had x squared minus 1. If you are familiar with quadratics and you know how to factorize quadratics and the types of quadratic expressions you can encounter, you will know that this is what we call a difference of two squares, and this difference of two squares actually contains a factor of x plus 1, so we could use x squared minus 1 as our common denominator, but we're not looking at things like that right now. We're just going to work with the one that we have here. So in looking at these two statements, both of them, the denominators are quite different, right? Although you are seeing an a here, that does not mean that a is a factor of a minus 3. Okay, so we are going to use our common denominator here as the product of a and a minus 3, and what that looks like is just simply writing a times a minus 3 in brackets, right? So writing it like this as well also allows us to be able to recognize the factors, right? Because when we have to bring them to equivalent fractions, although it might look like a headache to do right now, all you have to remember is this: you already have your common denominator showing you the factors. So when you consider how many times your denominator of a minus 3 can go into this product, you can just cancel off that common factor of a minus 3 and you remain with a factor of a. So this means we would have to multiply our numerator here by a. And we can immediately do that, which is just 2 by a is 2a. So I'm going to write 2a. Then on this side, I'm going to ask myself, well, how many times can a go into this product? And this is just as simple as crossing off the a's, and we would remain with a factor of a minus 3. So I'd have to multiply 3 by a minus 3. And while this one might not be as simple to multiply as the first one because we have brackets involved, we can just simply write out our statement so that way we can work on the further simplification as we move along, right? So we now have our statement for the numerator, and now we're going to simplify this further. So simplifying our numerator, we're going to expand the bracket using our distributive law. And what that gives me is, I have my 2a as I already had worked out from before. And now 3 times a is going to give me 3a. And 3 by 3 is going to give me 9. And because both these numbers have different signs, I have a positive 3 here and I have a negative 3 here. Positive by negative is going to leave me with a negative. So after this, I'm just going to see if I have any like terms to regroup. I'm going to put them together and simplify them, and 2a and 3a are already written close by. So 2a plus 3a is going to give me 5a. I don't have any other constants, so I just remove 5a minus 9. And I can leave my numerator as 5a minus 9. I don't have anything common there that I could probably cancel out with my denominator. And my denominator just remains as this product a into a minus 3. And that's all there is to it, right? We stop right there because, like I said, there are no more common factors. There's nothing further to simplify. And this is this statement in its simplified form. So if you understand how to simplify algebraic fractions, the next step after this is to solve equations involving algebraic fractions, and that's what we'll look at in another video coming up soon, so you can look out for that, right? If you know that these 2 questions kind of gave you a headache, you might want to take your time, look back at the video, slow it down. The last video would have covered a little bit more detail about the algebraic fractions, so you're welcome to take a look at that one all over again. And remember, if part of your problem is your basic little finding LCM, simplifying fractions, or even working with integers, you definitely want to go over those things before you jump back into this.